In the vast and mysterious corridors of science, some discoveries captivate our imagination, making us ponder the existence of entities beyond our ordinary reality. One such discovery comes from the pioneering scientist Dr. Daniel Nemes. He has made a name for himself with his groundbreaking energy device called Energy Vision. The claim of this device is extraordinary: to capture images of invisible beings. Dr. Daniel Nemes is a scientist specializing in quantum physics and energy research. He has dedicated his career to exploring the intersections of energy, matter, and dimensions beyond our conventional understanding. Over time, he became fascinated with theories of parallel universes and alternate realities. However, it is quite strange that despite publishing his findings, very little information can be found about him, and most of his work has been deleted from the internet. Some even claim that he disappeared shortly after sharing these discoveries. Nemes's interest in this research was inspired by the pioneering work of theoretical physicists who proposed the existence of multiple dimensions beyond three-dimensional space. Driven by his curiosity and desire to push the boundaries of human knowledge, Nemes began experimenting with new energy devices to detect and interact with these unseen realms. The Energy Vision emerged as a groundbreaking device, a result of Dr. Nemes's years of research and experimentation. Combining quantum mechanics, electromagnetism, and advanced imaging technologies, the device claims to capture images of entities existing in different dimensions. You might be wondering how the Energy Vision captures these beings that exist parallel to our own dimension. The device is equipped with sophisticated sensors and emitters, generating and detecting specific electromagnetic energy frequencies. The theory suggests that these frequencies resonate with the energy signatures of these beings, making them visible to the device's sensors. The captured data is processed by advanced algorithms and converted into visual images on a high-resolution screen. The device operates by sending controlled energy bursts into a specific area and then scanning for anomalies in the energy field. According to Nemes, these mysterious entities interact with energy fields in ways that can be detected by the Energy Vision sensors. The resulting images contain shapes and forms that do not correspond to any known physical entity, suggesting the existence of beings from different dimensions. If the device's capabilities are verified, it will have profound implications for science and our understanding of the universe. The ability to capture images of these beings would provide tangible evidence supporting long-speculated theories about the existence of parallel dimensions. This groundbreaking development could revolutionize fields like physics, cosmology, and even biology, as researchers explore the nature, characteristics, and interactions of these beings with our reality. However, despite the exciting potential of the Energy Vision, Nemes's work has faced significant skepticism and criticism from the scientific community. Critics argue that the device's claims lack empirical verification and that the generated images could be misleading. In response to the criticism, Dr. Nemes states that he has managed to capture several intriguing images of humanoid figures with the Energy Vision, which he claims exist between worlds. These beings have physical forms resembling humans but exhibit differences such as elongated limbs, ethereal appearances, and varying levels of transparency. The humanoid beings photographed by Nemes are characterized by their striking appearances and supernatural features. These beings often seem to be composed of a semi-transparent substance, suggesting a physical structure different from that of humans. Some images depict beings with elongated limbs and fingers, larger eyes than humans, and facial features that, while humanoid, differ significantly from typical human anatomy. The existence of these beings could support theories suggesting the existence of multiple dimensions and parallel realities. It could also prompt a reevaluation of fundamental scientific principles and potentially lead to groundbreaking advancements in fields like physics, biology, and technology. However, there are also concerns about the potential for misinterpretation of the images generated by the Energy Vision. In a field filled with uncertainties, it is crucial to distinguish between genuine scientific discoveries and phenomena that can be explained by known physical processes. Careful analyses and verification with other research findings are necessary to avoid premature or erroneous conclusions. Daniel Nemes's work with the energy vision fits into a broader research context encompassing theoretical physics, metaphysical studies, and various scientific disciplines. Theoretical physicists have long debated the possibility of parallel universes and alternate realities. The images captured by the energy vision could provide physical evidence supporting these theories. The concepts of parallel universes and alternate realities have moved beyond science fiction narratives and become subjects of scientific inquiry. Theoretical physicists have long debated the possibility of parallel universes and alternate realities, proposing different models. According to these theories, our three-dimensional universe is part of a much larger and more complex multiverse. Nemes's work attempts to bridge the gap between these theoretical models and empirical observation. This research also fuels public imagination, increasing interest in science fiction and speculative fiction. The idea of parallel worlds and alternate realities resonates with fundamental questions about the nature of existence and our place in the cosmos. While the multiverse theory remains one of the most controversial in the scientific community, there are scientific ideas supporting the existence of parallel universes. The vastness of our universe is mind-boggling. Space is filled with hundreds of billions or even trillions of galaxies, each hosting billions or trillions of stars. Some scientists estimate that the diameter of the universe could extend up to 7 billion light-years, while others believe it might be infinite. The existence of multiverses and parallel worlds is often discussed in conjunction with significant scientific concepts such as the Big Bang, string theory, and quantum physics. The mysterious phenomenon of inflation and the Big Bang have convinced some experts that the existence of numerous universes is plausible, even highly probable. According to Alexander Vilenkin, a theoretical physicist at Tufts University in Massachusetts, inflation did not end everywhere at the same time, which might have led to the formation of different bubble universes with different laws of physics. Although cosmic inflation ended 13.8 billion years ago, as far as we can observe from Earth, it still continues in other regions of the universe. This concept is called eternal inflation. In an article he wrote for Scientific American magazine in 2011, Vilenkin states that a new bubble universe emerges when inflation stops at a particular location. The disconnection between bubble universes is due to their continuous expansion. Even if we embarked on a journey towards the boundary of our cosmic realm, where it potentially intersects with an adjacent cosmic realm, we couldn't reach it. This is because the boundary is moving away from us faster than the speed of light. However, based on the concept of eternal inflation and string theory, our known universe, with its specific physical constants and conditions suitable for life, could be entirely different from the hypothetical bubble universe. Some scientists derive the concept of parallel universes from quantum physics, which is the mathematical representation of subatomic particles. In the world of quantum mechanics, tiny particles can exist in multiple states simultaneously, made possible by a wave function encompassing all these potentials. However, upon closer examination, we only observe one of the potential outcomes. As explained in the Stanford Encyclopedia of Philosophy, according to the Copenhagen interpretation, we perceive an outcome when the wave function collapses into a single state. But the many worlds hypothesis proposes that when an observation is made in a particular state or outcome, a separate world is created where a different quantum outcome occurs. This is a diverging configuration where our observed universe branches into almost limitless possibilities at every moment. Since parallel universes are entirely separate and impossible to intersect, you would never be aware of the many copies of yourself living slightly or completely different lives in these other worlds, even if they exist. Some physicists believe in a flatter version of multiverses. If the universe is infinite, There are a limited number of possible arrangements for the building blocks of matter to come together in boundless space. Ultimately, the finite number of particle types will inevitably repeat a particular arrangement. In theory, in a sufficiently large area, such particles will inevitably repeat configurations on scales as large as entire solar systems and galaxies. Another basis for the concept of parallel universes lies in cosmology, particularly in the theory of cosmic inflation proposed by physicist Alan Guth in the early 1980s. Cosmic inflation postulates that the universe underwent an exponential expansion shortly after the Big Bang. This rapid expansion might have created pocket universes within a larger multiverse, each with its own unique characteristics and physical laws. This inflationary multiverse suggests that our observable universe is just one of many bubbles within a vast and possibly infinite cosmic landscape. String theory is a theoretical framework proposing that the fundamental particles constituting everything are one-dimensional strings. Different vibrations of these strings can create different particles and different universes. String theory predicts a multitude of possible universes, further supporting the idea of a multiverse. The many worlds hypothesis asserts that at every moment of observation, the universe splits into countless parallel universes where different quantum outcomes occur. These universes are entirely separate and non-interacting, so you cannot be aware of your other versions. Some physicists believe that in an infinite universe, the building blocks of matter can only combine in a limited number of arrangements, making the repetition of the same configurations inevitable. Therefore, in theory, structures like our solar system and galaxy could repeat in a sufficiently large universe. Another foundation for the concept of parallel universes is found in cosmology, specifically in the theory of cosmic inflation proposed by physicist Alan Guth in the 1980s. This theory suggests that the universe experienced rapid expansion shortly after the Big Bang, potentially creating pocket universes with distinct characteristics. Thus, our universe could be just one of countless bubbles within this vast cosmic structure. String theory also lends support to the idea of parallel universes. It proposes that everything is composed of one-dimensional strings, and different vibrations of these strings can generate different particles and universes, pointing to the existence of numerous possible universes. Cosmology and quantum computing may offer new tools and techniques to explore the mysteries of parallel universes. Although direct evidence has not yet been obtained, the quest to understand parallel universes fosters innovation and expands our scientific horizons. The idea of parallel universes fundamentally challenges our perception of reality. If there are multiple versions of reality, each with its own history and events, what does this mean for our understanding of the world? For now, the mysteries of parallel universes push the boundaries of our understanding of reality, opening new horizons in science and philosophy. The theoretical foundations in quantum mechanics, cosmology, and string theory provide plausible frameworks for the existence of multiverses, while scientific implications lead to technological innovations and new research areas. Beyond the scientific and technological aspects, parallel universes raise profound philosophical and existential questions about the nature of reality, free will, and the ethical dimensions of our actions. If there are countless versions of ourselves who have made different choices and experienced different outcomes, what will be the meaning of free will? Will the consequences of our actions be valid only in our universe, or will they also affect our versions in other universes? These questions can also deeply impact our understanding of moral responsibility and ethical values. Parallel universes also challenge the concepts of fate, chance, and probability. If every possibility occurs in a different universe, is our destiny truly predetermined? Or is it just one of infinite possibilities? What will be the role of chance and coincidence? While there are no definitive answers to these questions, contemplating parallel universes allows us to reflect more deeply on our own existence and our relationship with the universe. As scientific research progresses, perhaps one day we will gain more knowledge about this mysterious concept and find more satisfying answers to these questions. But for now, parallel universes remain one of humanity's greatest curiosities and will likely continue to challenge our imagination. In this section, we took a closer look at Dr. Daniel Nemes's groundbreaking energy vision device and his research on parallel universes. This device, which claims to capture images of these mysterious entities, has caused a significant stir in the scientific world and ignited discussions about the existence of parallel universes. Although scientific evidence is not yet conclusive, this research prompts us to question our understanding of the nature of the universe and our own existence. In the next section, we will examine different scientific theories about parallel universes and their potential impacts on the scientific world and humanity. What clues do these theories, which push the boundaries of science fiction, offer about the nature of reality? What opportunities and threats do parallel universes hold for humanity? We will be waiting for you in the next episode of our documentary series to seek answers to these and many other questions.